Okay, here's warm-up 9.3. We're going to be using the unit circle here. I've got one printed on here that's all filled out. And we're going to be using these definitions of sine, cosine, tangent, and also the reciprocal functions that involve the x and y coordinates at these special places on the unit circle. So when we're finding the exact value, yeah, I could put these into a calculator. Sometimes you will get the exact value, but not always. So I want to use these definitions to make sure I can get an answer that's in simple radical form. So for cosine is going to be the x value. The way I remember this is x comes before y alphabetically, cosine comes before sine. So the cosine is going to be the x, the sine is going to be the y. Okay, so cosine at 30 degrees, well, here's my 30-degree angle. So I'm just looking for the x value there, which is going to be √3 over 2. And yeah, a calculator would give you something equivalent to that, but it would be a decimal approximation. Or roughly equivalent to it, okay? All right, so for sine, I'm going to be looking for a y value, all right? So I'm going to find 2 pi over 3, this is in radians, but 2 pi over 3, there it is, okay? And then I'm looking for the y value then at 2 pi over 3, which is also √3 over 2. Okay? Tangent is going to be y over x. So I'm looking for 30 degrees. Well, here's 30 degrees again. So I'm going to do here my y over my x. So this is going to be 1/2 divided by √3 over 2. Okay? Now, I can write this as division. I need to clean this up when I have a complex fraction with more than 2 layers like that. So you can write it as division. What's going to end up happening is the 2's will cancel out. Okay, so it's a little shortcut. When you have the same denominator on the top and the bottom, you can kind of just cross them out. I'm going to get 1 over √3, which I'm still going to have to do a little work for. But let's say you didn't notice that. So I'm doing 1/2 divided by, or you didn't know about that shortcut. You can still just treat that fraction like this, right? And then we can write this as multiplication by flipping the second fraction. Okay, and then we can combine this into one fraction. So I've got 2 over 2 √3. Well, now the 2's cancel, right? Just like I promised they would. But you still have to show that the √3 is in the denominator. So I've got 1 over √3. Okay, now I've still got a little further to go because I've got a radical in the denominator. I need to rationalize that denominator like this. And then I'm going to get √3 over 3. So this is going to simplify then to √3 over 3. I didn't have enough space there to work, so I did my work here. Okay. All right. Secant is going to be 1 over x. That's my definition I'm using here. So 5 pi over 3, let's find that. 5 pi over 3 is going to be right here. 5 pi over 3, and I'm going to use 1 over the x value at 5 pi over 3. So I've got 1 over 1/2. Okay? So I don't want to leave that as a complex fraction like that, so let's think of this as division. 1 divided by 1/2. Well, that's the same as 1 times 2 over 1, which is just 2, right? So 1 times 2 is going to be 2. Okay, and that's exact. All right, and then sine of 405 degrees. 405 degrees isn't on here. Well, the number itself isn't written on there because it only goes up to 360, but remember you can keep going around. So if 360 is one full rotation, but if I wanted to add another 30 degrees to that, I just keep going another 30 degrees. We're using this like a clock, okay? So if you do 360 plus 30, that'll put you at 390, but if we do 360 plus 45, that's going to put us at 405, right? So just to show you, yeah, this 405 degree angle, there's the initial side. My terminal side, I'll go around 360, and then I'll go another 45 degrees. So it still lines up with one of these special angles. So that still is going to put me at the same position for 405 degrees. So I'm looking for For sine, this is my y value, and my y value here is going to be root 2 over 2, and that's already in simple radical form, and it's exact, so I'm done. And that's the end of the warm-up, and I'll see you next time.